So, Bismillahir Rahim. Welcome everyone to the second workshop by the GDG OC Club at Abu Dhabi University. This is going to be the second workshop in a series of Blue Team Basics. Today we're just going to be having an overview of what Linux is, and we're just going to get our hands dirty with a very basic commands in the Linux command line. So what are we exactly having today? We're going to be having a definition of what Linux is, why is it important, some statistics about it, and a brief history about it. Not really that much, because we don't really care about the history of Linux. It's not going to teach us anything technical, to be honest. You could do your own research if you wanted to. And then we're going to be talking about few commands of file systems, processes, networking, and logs redirection. And then I will give you a tip about how could you actually start into using Linux, or what are the resources to teach you to use the actual hardcore Linux. Great. Just a quick overview, just like last time. I'm a second-year cybersecurity engineering student at Abu Dhabi University. And Linux, I use it as my daily driver, and I am interested in the red team aspect, especially the red team aspect that is specialized in low-level security. My name is Abdulrahman Tamim at LinkedIn if you wanted to find me. And this is my email. If you have any questions or concerns about the workshop, I would be more than happy to listen to any of your suggestions. Great. So we shall get started. So what is Linux? So us as IT students, no matter what we are, software engineering or cybersecurity or computer engineering, we use computers every day, and it's our specialty. And the whole field is centralized about them. Now, most of us, probably, I would say 99% of us, uses Windows and Mac as our daily drivers, as laptops, because they give us accessibility. They give us, they're common, right? We are regulated to use them since we were maybe in high school or in middle school. And so the percentage of Windows usage, the high percentage of Windows users in this society, in the technical society, it had taken over the market, the laptops market. So that's why we use Windows. And we're not really familiar with what Linux exactly is. And that's what we're going to do today. So Linux, unlike Windows or Mac, it's an open source operating system. You could literally go to GitHub and read the source code of this operating system. Well, why is that interesting? Well, because you know what you're running on your computer, right? When you run Windows or Mac, you don't have access to the source code of these operating systems, because these are commercial software. You pay for them, right? You pay for a MacBook, a whole hardware just to get the Mac operating system, and you pay for a license key. Usually you pay for a license key for the Windows operating system just to get access to them, even though you don't have access to the source code. Linux is unlike those. It's more secure, it's more customizable, it's free and open source, and it has power. You could literally do whatever you wanted on Windows or Mac. You could do that on Linux. People could tell me I can't do gaming on Linux. Yes, you can, and I do gaming on Linux. You cannot use documents. Yes, you can use documents. You can use a browser. You can use coding. You could use any sort of software. If you became a developer yourself, you're going to love using Linux. And we're going to see some statistics about these network in a second. So today our focus is about the command line. Linux is a massive ocean. We can't just it's a massive ecosystem. We cannot just explain everything in one workshop. It's we have a really short time, but we're going to learn some commands today, and we're going to learn what is it exactly. That's all. We're not going to really have a deep dive into it because we don't really have that much time for it. But if you guys wanted us to get deeper into Linux, I would be more than happy to make another workshop. We're going to be talking about file systems and permissions, just how to serve files, how to make files and directories. We're going to also understand what permissions are. We're going to learn about outputs and redirection. How could we store our outputs in the commands? Also, we're going to learn some basic commands in networking, okay, and process monitoring. So don't really expect much from this workshop. This is just an introductory to teach you what is Linux actually like, just to give you an idea and an overview of what how would I feel if I used Linux as my daily driver. But of course, what not to expect. We're jumping to this point right now. What not to expect, the first thing not to expect is there's no graphical user interface. Okay, we're going to be using a fully command line space or environment. Okay, there will be no graphical user interface. You're not going to be clicking buttons. You're not going to be moving windows from left to right, up, down, minimize, maximize. There's no that. Yet Linux does support these, but we're not going to use this today for two reasons. The first one is that I cannot host these for you guys. I have my own server actually right now, and I'm hosting. Inshallah, we're going to have this today. I'm hosting it for you guys to access the Linux maybe for the first time in your life. So and so hosting a graphic user interface for like 10 students or 20 students is going to push my server to its peak performance, and I don't want that to happen because I'm hosting other services on it. And also the aim of the aim of this workshop is to teach you the command line basics. Okay. And the third option is that when you go to the job market, you're not going to fully rely on the graphical user interface, because most of programs on Linux, most of the core utilities are built in a command line. They're not built in a graphical user interface. And the fourth reason is that it's much more faster. When you regulate your hands on working with the command line, and I'm talking from a personal experience, you're going to sort of you're going to save a lot of time for yourself. You're going to sort of build an expertise in this command line skill that will give you ability to, first thing, elevate your career, and at the same time understand computers better. And that's what Linux did with me. Okay. So as I said, we're going to be using command line interface, but these are just a glance on what you could design about your Linux desktop. It's as you see, it's really beautiful. People customize. This is just different screenshots from people on Reddit have shared their desktop customizations. I think it's extremely beautiful. I have gone into this rabbit hole of what we call rising. You know, when someone optimizes their car performance, like we do rise the car, whether it's about the performance or it's about the design from outside. Yeah, that's similar to what they're doing here. What they're doing here on Linux. They design the fonts, they design the colors, the backgrounds, generally everything about the system. They customize it in the way they want it, because Linux is an open source operating system, and you could do whatever you want with it. So just wanted to introduce you to some names. These are called desktop environments. And if you go back to this screenshot, I think this is a Cinnamon desktop environment. So each of these desktop environments, their job is to take this CLI interface and convert it into a graphical user interface that beginner users will use. Also, not just beginner users, because there's a lot of programs that cannot be supported on a CLI, right? Like a browser or a document reader, or maybe a video editor. So anything that works on Linux that requires a graphical user interface, we need to install a specific desktop environment for it. Now, if you decided after this workshop, inshallah, to move to Linux, or at least install it alongside your Windows operating system, I recommend for you to start using KDE Plasma. It's my favorite. And when I started using Linux 2 years ago, I have personally used KDE Plasma on the distribution of Linux called the Fedora. But these are just also a bit advanced in troubleshooting and usage. But I recommend personally using KDE Plasma. I'm currently on the system that I'm sharing the screen from is currently using GNOME, as you see. It's the GNOME operating system. It's the GNOME desktop environment that is based on Linux. Okay, it's a distribution called Arch. Okay, so just so you know, if you plan into starting in the future, put in your mind that I want to use Linux that uses a desktop environment of KDE Plasma. Okay. Also, we're not going to get into internals in this workshop, okay? This is just, as I said, again, it's just a basic overview of what Linux is, how to use basic commands, and how to serve the file system, okay, and how to view the processes. Linux is a massive ecosystem, as I said, and development in it is a mistake I've done before is that I have got into these topics for fun, and they are extremely, not what I wouldn't say difficult, but they're extremely dense. And so my advice is, if you decided to career in low-level security, if you decided to career in software engineering, and you are asked to whether secure software on a security system that uses Linux, or reverse engineer, in advanced scenarios, you need to reverse engineer a computer virus to understand its activity on a Linux system, understanding the operating system internals and developing on the operating system is crucial. Similarly, if you're doing a software engineering and you are asked to build a native app on Linux, an app that runs on Linux, it's totally different from an app that runs on Windows, right? They both have different architecture, so you must scale your skills. You must build a different code base for the Linux version of the software. So learning also the OS development and OS internals in that case also is important. But anything else, I do not recommend getting into this rabbit hole. It's useless unless you want to level up your career. You could get into that. I would be more than glad if you have any questions about Linux or how to get into it, how to get into its internals. It's a pretty fascinating world, but it's painful at the same time. But having skills in them is really useful for as a future career. Great. So just so you now have an idea of what we're going to do in this workshop, this is a setup of my home right now. So I'm going to give you a command. Okay, each one of you, you're all going to connect to my SSH server, and every time one of you connects to the server, you do not get a shell on the server. We're going to talk about what a shell is in a second now, but you do not get a shell on the server directly. You get a Docker container, which is a simulated computer. Sort of, you never heard of Docker containers? It's sort of simulating on a whole operating system or a service or an app. It really depends on what you're simulating with it. But it's for our situation, we're going to be using a Debian, which is a type of Linux. Okay, so each one of you will have a shell on their own Docker container for two reasons. The first one is that nobody compromises the security and the privacy of any other student. Maybe we have pro hackers in this workshop. Maybe, I don't know. I would be honored to have you guys. So that nobody compromises the security, because if all the students connected to the same server, I could be able to view your IP addresses. If I connected with you guys, if I could be able to view your IP addresses, I could be maybe compromise your devices. So for security and for the sake of privacy of all students, I have isolated all your connections into each one of you will get a Docker container by themselves. The second reason is that I'm not willing to endanger my server. Okay, if anybody maybe malicious could be connecting to my server, because I'm hosting sensitive content on the server, and so I would be I would be endangering my server. So we're going to run a command. Okay, you don't need to think about this whole complex thing. Okay, just we're gonna run the command and start using the shell. Okay, this is just an overview for anybody who's watching the recording later as a professional, maybe just to have an idea about the setup that we have. Great. So I wanted to talk about a brief history. I didn't want it to make a whole like 5 slides about what history is it, what exactly, who did that, what, and it's not going to really help us, right? As I said earlier, it's not going to get us the internship that we wanted. But just to have an overview of what Linux is a software that is built by several people. It's not built by one person. So it's a staged, there's some sort of a stages that the Unix which came before the Linux operating system, sort of a stages that came through or going through, so that it had reached the final product that we have today. And generally, originally, it was made by Bell Labs. Okay, it was called Unix, as you see in here. It was called Unix, and it introduces the philosophy that everything is a file. And then we moved on to the GNU project, which basically makes apps for the Unix, right? Unix wasn't really an operating system. It was more of a it free define the operating systems, but I can't really say it's an operating system. Okay, and then the GNU project came. Okay, so by Richard Stallman, he's a guy who built apps for the Unix utilities that we're gonna use in a second now, but then we have Minix, which also it's an operating system to that inspired a guy called Linus Torvalds. Okay, he's the guy who made the kernel, okay, as a hobby, as he said, and he's the reason why we have today the Linux operating system that millions of servers around the world run on. But to be more precise, he built the kernel. The kernel is the brain of the operating system. It's the central software that the operating system uses to communicate with the hardware. It's like the bridge between the software and the hardware. And so people came on, and when he published his code, people came to GitHub, and everybody started contributing to the project, especially the GNU project by Richard Stallman. So people mixed both GNU and Linux kernel, so the brain of the operating system, and started building utilities above them. And then we have this beautiful operating system that is open source, and the whole community of developers, a whole community of developers is contributing to it. And so we have also Slackware and Debian appear, the first distributions. We have a family of distributions in Linux. So it's a bunch of developers that gathered and, hey, let's make Debian. Or, for example, let's make Ubuntu. So each of these distributions have, I wouldn't say they have their own use, but they have their own taste. They have their own customizations. And so you're really free to use any of them depending on your needs. Okay. But as a beginner, I would recommend using Debian or Ubuntu. There are much more distributions. Personally, the laptop I'm presenting from is using Arch Linux, which I think you have heard about it before. I'm personally really satisfied with Arch Linux, and I use it as my daily driver in university, in programming, in hacking, and even in gaming. So also another fun tip, and fun fact, your Android phones is running Unix as a kernel, okay, or as an operating system, as a original operating system. Android and Huawei and Oppo and all of these Android-based phones, they are all based on Linux. There's about 4 billion devices, I believe. Runs billions. Yeah, I think there are 4 billion devices, and they all running Linux in a root sense. Okay, and so we have came to a point where Linux is everywhere in the world. Okay, and that's why if you're getting into IT, one day in your life you will be facing Linux. Maybe you're not going to face it now, you're going to face it later if you're trying to expand your career. Okay, so Linux is extremely important. So we have talked a lot about what time it is. Oh, we have talked for like 20 minutes. So what have Linux impacted the world? How is it impacting the world? Hospitals, governments, companies, everybody is using Linux. Okay, and if you could look at the Linux usage in globally, like how websites use Linux to host on their own servers, and the top 1,000 server, 49% of them uses Linux. So there is a high possibility that when you work at a company, you're going to be using whether Linux on their computer, or you're going to be troubleshooting as a cloud engineer. You're going to be troubleshooting something on the cloud. Linux is performance friendly. It's very customizable, as we said before, and it's secure. That's why a lot of companies prefer using Linux. And so you can take a look also here at the market share. As an operating system, 5% of people that use computers do use Unix, okay, or Linux. But we did not include the Android, by the way. So there's like 4 billion devices that are based on Unix also. So that's another whole thing. Maybe the percentage will increase more than Windows. I'm not really sure. I didn't do the calculations, but just so you have an idea. So Linux is being used by many governments, by many companies, by employers themselves. Look for Linux as a skill. If they saw Linux in your resume, that would be fascinating, because a lot of students who graduate do not have these skills. And I personally recommend for you to at least install a virtual machine, get yourself familiar with Linux. Yes, there's a steep learning curve, but it's really worth it. It's going to at least take you 1 month, 1.5 months to learn the basics of Linux, being able to survive in it. Okay, great. So let's minimize this and go to the next slide. What are different things? What are different careers? Linux in different careers. What can I do with it? Well, if you think you're software engineering and you can't escape Linux, I am not really sure about it. But most of the time, you're going to be facing Linux, especially if you want to be an elite software engineer. If you want to be someone who's a cross-platform developer, you develop websites, you develop apps for Windows, you develop apps for Linux and Android. So you're a mobile developer. So you're someone who's comfortable using Linux and as a skill. That's extremely important. Talking about cybersecurity, guys, we're not going to seriously have this discussion. If you're cybersecurity and or you're IT and you're planning to go to cybersecurity, Linux is your #1 path. If you're going to start in something, starting after Python or starting after networking, Linux is extremely important. Okay, you're going to be facing Linux for a very long time. You're going to be sitting on the terminal for a long time because most of the tools, whether defense or offense, uses Linux. Okay, they're natively built for Linux. Maybe you could run them on Windows, I'm not really sure, but most of the tools and the utilities and the scripts are natively supported on Linux. And also it's much easier to run programming languages on Linux. It's much more easier to set up. Okay, for general IT, if you're going to work at some sort of an environment like cloud, or maybe you work at a company and they use Linux as their hosting website or something, knowing how to quickly access the server through a remote shell and just connect to the server and start typing commands is going not just to make you look cool, but it's going to elevate your career. They're going to look at you and they're going to price you as an expensive employer. You're someone who's valuable for them. Okay, you're a valuable entity and a valuable investment for them. So let's move on to online opinions. Linux talk. People on Reddit talk about different opinions on the about the Linux operating system. So if you could look at the different opinions here, a lot of people start recommending it, whether about the job market or about the or about using it. So you could also look it up yourself. They're recommending it to use the programming languages, recommending how light it is, and how could you start in it. Reddit is full of these opinions. I personally recommend for you guys, if you are confused about anything about Linux, you could ask me. You could go to Reddit. You could ask ChatGPT. I think ChatGPT is going to be your best friend into starting out with Linux. Okay, so I have talked enough. Let's get started. How much have we spent? About 30 minutes. Okay, so oops, nope, we don't want this. Okay, so we will start out with the file systems and permissions. But before we start, guys, I want to start with the first connection here, just so that we could start at the workshop. So I want each one of you, if you use Windows, I want you to raise your hands. I want you to raise your hand if you use Windows, please, because I just want to see how many of you does use Windows as their operating system on the laptop. Okay. Until now, we have 7 raise their hands. Okay, so the rest does use Mac, or okay, 9. Let's just wait. Okay, I'll be sending the command in the. Okay, great. So before you connect to anything, guys, how many of you have used Windows? We have 9 uses Windows operating system. Okay, great. It doesn't really matter actually. So if you use Mac or Windows, it doesn't really matter. It works on both, but just so I have an idea about the audience, 10 of you. Okay, great. So what are we exactly doing in this lab? We are basically connecting to a server that I'm hosting in my house. Now, it's a pretty simple syntax, okay? You're gonna go to your terminal, and on the Windows, I want you guys, all of you now, open the CMD, okay, please. Go to your Windows on the search bar. Yeah, lower your hand, it's fine. Go to the search bar and type in CMD, okay? I want you to type in CMD. And once it's running, okay, get ready to run this command, okay? So this command, basically, before you connect, just so you have an idea about it, we are connecting to an SSH. SSH is a command that gives you the ability to have a secure shell, okay? I'm going to explain in a second what a shell is, inshallah. A shell, so it gives you ability to connect to a secure shell, which gives you ability to control a computer remotely, okay? So you're going to have a session on my server remotely that is a Linux server. You're going to have a shell, okay? A shell like this. You're going to have a connection to the terminal, okay? You're going to go SSH, Mr. SSH, I want you to connect me to this user at, okay, at this computer. Okay, this is not an IP address but I have hidden it behind the DNS name. I've got my own DNS name for this workshop, for the sake of this workshop. So you're gonna be like, connect me to this user on this server at the server. Okay, and then I'm gonna give you the password, guys, now after I give you the command. Okay, so yes, exactly, the command prompt. It's called the command prompt. So you are going to copy the command. Let me just look up for bash for the best view. You're going to, guys, copy this. Okay, it will ask you a question. Do you want to add this to keys or something? I'm sure it will. And then you're gonna type in yes. Okay, after that you're gonna type in this password. Okay, GDG OC 2025. Okay, in this way I could see how many of you have spawned a Docker container on my server. So let's just wait. How many of you have access to the machine? You run the command, type in yes, and then paste in the password, copy it and paste it in the CMD. If you're using Mac, it's similar. You could go to the terminal also and run that too. Okay. Let's see how many of you could connect. Let's just wait for you guys. If it didn't work, please tell me, guys. Oh, we have the first connection. Great. Hopefully we have at least in 2 minutes, we have 20 connections. Come on, guys. Yalla. I'm waiting. We have 3 connections. Great. Okay. Don't do anything. Once you connect, we're going to start. Okay. You guys, you connect, and I'm just going to go get water because my throat is hurting me. I'm coming in a second. Wait, until now, we have just 3 connections. I don't know why you guys... We have 25 attendances and we only have 3 connections. Oh, okay. My bad. We have until now about 10 connections. That's great. I'm waiting for you guys. We're going to give you extra 1 minute and then we're going to get started. Okay. Anybody have any difficulties running the commands? If you have any difficulty, just tell me. Okay, I think 1, 2, 3, 8 of you is connected. Okay, all good. Okay, I don't want to procrastinate more, so we shall get started. Great. So after you connect to the SSH, oh, wait, that's weird. That's key exchange content by port 22. That's weird. Okay, all of you are connected, but it's not connecting for me. That is weird. Are you guys facing the same problem, or? Okay, it's fine. I'm just going to connect to a local host because it's hosted locally on my device. Okay, great. So until now, we have approximately about 10 connections. Yeah. Okay. So type in the password and we shall get started. Okay, great. So we are connected to a Linux shell right now. This is probably your first time, I think, connecting to a Linux shell. It's extremely simple. There are several commands you must know in order for you to be able to navigate the file system and be able and be comfortable using it. Okay. So yeah, there's most of you here. There's about 10 or 11. Okay, great. So we shall get started. I think I've given you guys enough time to connect. Okay, So just so you understand what a shell is, I want you to, okay, let me, operating system shell. Okay, so a shell, let me find a good diagram in here, because these circles, I don't like the circle diagram, but let's just find out a good diagram. Unfortunately, I did not. Okay, let me sort of okay, this is a good diagram, I believe. Is there any other one? Just so that you guys understand it in a better way. Okay, so imagine you are the user, right? And a shell is what you interact with. Okay, you are at the applications level. You're running Google Chrome, you're running VS Code, okay? And so when you connect to a shell, okay, a shell is a program, it's a part of the operating system that lets the user control the file system, control the processes, control the memory. So the shell is a program, it's just one of the programs in the operating system that gives the user the ability to control the operating system, okay? Now, the shell is connected to the kernel, okay? The kernel is the central process or the central program of the operating system. Kernel is a really massive program. It contains a lot of lines of code, millions of lines of code. Is one of these programs. Okay, gives the user the ability to interact with the operating system. Okay, which consequentially interacts with the hardware. Okay, so why do we call this a shell? Because in a Linux technical term, we call this a shell because it is a shell program that gives us ability to control the memory, as I said, the files, the operating system services and processes that are running. And that's why we call it the shell, okay? That's what we're trying to do today. We're trying to be comfortable working with the operating system shell. Now, of course, we are not directly working with the actual literal shell that is run on Linux. No, we are working with the shell that is layered. This is a bash shell, okay? There are different types of bash shell. Let me show you different types of shell. Now, not shell, I mean in operating systems. So different people have developed different programs to communicate with the operating system or give you the ability to communicate with the operating system. Okay, dash CSH. I wanted to make this workshop as a searching on Googling together so that it makes it a bit more interactive. Okay, so these are okay, this yeah, here we go. This is a good overview. This is the user. You interact with the shell and the applications, and they automatically connect to the utilities that are part of the kernel, and you interact with the hardware. Now we have different types of shells. Okay, we have different types of shells here. Let's take a look at them. We have the KSH shell, and we have the bash shell. These are different programs developed by different people, different developers, and these programs let you interact with the memory, let you interact with the files, as I said. Just remember what a shell is so that you could actually understand what is going on. Okay, great. So mashallah, we have about 11 connections. Great. So let's get started. Enough talking. Let's get started to it. Okay. So in order for us to list files, see processes, we need to know specific commands, right? There are commands that you run on the terminal that gives you ability that are pre-programmed into the shell, okay, into the operating system that you're using. As we said, low-level utilities, as we saw in the diagram, they gives you ability to interact with the operating system, okay? One of the very first commands that we're going to learn is going to be ls. Okay, now ls is going to be your, I think most of you never use Linux, so this will be your very first command to run. You're gonna type in ls, okay, and I want you to type in ls and click enter. Okay, so what do we have in here? We have a file. Apparently we have a file that says workshop files. Let me show you guys in a graphical way these GDG workshop. Okay, great. Yeah, let's put this on the left side. Guys, ignore these, okay? Please just ignore these two files. We're just working on this one, okay? I'll put this on the left, okay? Now, where are we exactly? We are, oh, oops, my bad. We're not really here. Yeah, okay, so where are we exactly? I'll just go to the actual machine. It's better. Yeah, we're here. Great. So when we do ls, it lists us the files that we are in currently. Okay, we are at this folder. Okay, we know, guys, folders are boxes that contains files, right? So when we do ls, we list the files that we have in front of us. I have opened this directory which is called home, hex, and then this folder. Okay, these are a bunch of folders that contain other folders, right? And so when I do ls, it prints for me the files. Okay, now this is just the native system for me, so it will print information automatically about it. But if you go back to our system, okay, and you type ls and then -l and click enter, it will show you the files that are set up on your Docker container. This is how could we tell if this is a folder or a file? Well, you go back and read the information about the file. So when you do ls-l, you are listing information about the folders and the files, things in the current directory. Okay, and so you could read it in here. The first, okay, let's go back to these slides and see and take a look at what is exactly going on. Yeah, great. So I want you to imagine which one is better to read. Okay, yeah. Great. So I want you to look at this one here. I actually was, I wrote this. Oh, I didn't. Okay, so look at this diagram. It's similar to the output we had. First thing, we have the permissions. We're going to talk about these in a second. The links, we don't need to focus on this. And then we have the owner and the group. Okay, so there's a group and a user, the guy who made the file, okay, or the folder, which is you, called student, and the group. So student is part of a group student. Okay, and then we have the date it was made and the time, and then the file name. Now let's talk about permissions, what they're exactly. Okay, so before we move on to permissions, I want to focus on the other commands. Make dir folder name. So what is make dir? Let's go back to the files. Okay, so imagine I want to make a folder. Okay, and I don't want to make a Word document or a PDF. I want to make a folder and I want to put stuff in it. I will use the second command, which will be make dir. Okay, and then I want to name the folder. Let's name it test. Okay, so you're gonna type mkdir space. Okay, commands accept parameters after you type them. So you type the command and then you put in a name for this the folder. So we click enter, and boom, we have made a directory. Now, when you work with a CLI, you do not see this graphical user interface. You just see the CLI. So how could you make sure that this file was created? You don't need to make sure it was created. Of course, it will be created if it didn't print any errors for you. But just to make sure, for the sake of learning now, we will make again ls, and we could see again there is a file that was printed for you. It's called test. If you go back to our machine, the Docker container, you could do make dir and then test. Okay, you click enter and then you do ls, and you can see there is a folder called test. Again, if you do ls-lha, you will find information. Oh, sorry, not lha, just -l. Okay, -l, you will find information about the file. Okay, now we're going to learn the next command. What is the next command here? Which is touch. Okay, now touch doesn't make a directory, doesn't make a box to put stuff in it. No, it does make the file that contains actual data. So I want to make a Python script. I'm sure you guys worked with Python script before. So we're going to type in touch space, and then we're going to type in script.py. Okay, you need to specify the extension of the file so that the operating system could tell what is this file exactly. Maybe we may not specify it. It's totally fine. You could just fill it with text or fill it with whatever you want. But if you want to use the file later, whether to execute it or run the script or whatever you want to do with it, the operating system recognizes the file through the file format. So we say touch space, and then it's expecting a file name. So we touch script.py and then click enter. Great. We do ls again. We see that there is a file called script.py. We had made a file called script.py. Great. So we have learned how to make a directory. We have learned to see what are the files exactly in the current directory, okay, that we are in, and how to make a folders. Okay, so we have learned these three things. Okay, did I miss anything? No. Okay, so let's make this again on my actual system and see this on the graphical user interface. Touch. Let's call it home.py. Okay, so it had made the file, the Python file, home.py. Great. So The next one is going to be cat. Okay, cat. But before we learn about cat, I want to teach you guys about a command that helps us to navigate into folders, to get into folders. Okay, so we have this directory. We know this is a directory. How did we know that? If we could look back at the output we did, ls-l, we could see at the very beginning we have a D. Okay, let's explain these now. Okay, so look at these letters. Okay, what do they exactly mean? They don't make any sense for me. What they're exactly meaning is that the first space, or the first byte, is explaining. We call this a byte, okay, or a character. The first character is about what the file type is. Okay, if you go down here, the file type, if it was D, if it was a dash, sorry, if it was a dash, it would be a regular file. Okay, and if we go back and do ls-l, we see that script.py is just a dash at the beginning. It tells us that it's just a dash, right? It's not an actual directory. It's not a box that we put stuff in. It's not something we could enter. It's something we execute or read, okay? And then we got D for directory. So when we did ls-l, we knew that D is a directory, which means we could enter this directory. How could we enter this directory? How could we go back to the, let's go back here. How could we just click on this and get into the file like this? In the GUI, I just double click on it and get inside it to see what's inside, right? Well, in the command line, we use a utility that is called cd, which is short for change directory. cd space, and then we specify the file, the folder name, not the file. Okay, so if we did like cd script.py and click enter, it says script.py is not a directory. Okay, so it will not be able to get into script.py. So we need cd, and then we said workshop. Now we did the w as capital. Okay, and then we said workshop dash files. Then we click enter. It says no such file or directory, even though it's literally the same name. Okay, but remember, commands on Linux are case sensitive. Okay, cd, we're going to review everything in a second now, guys. I know I'm mixing things up right now and it's a bit of a rush, but I hope you guys are following up with me now. cd, and then we make we get inside the folder. Now wait a minute, you do not type the whole name. Okay, wait, cd space work, and then before you type the whole thing, maybe folder names could be really long strings, right? We're not going to type the whole thing. So what we could do is that some Linux shells support auto-completion, something we call auto-completion, where you do cd space, and then when you type some part of the folder, okay, that is unique, that makes the folder name unique. Like when I type work, there's no other folder or file that is work. Okay, so I just type in work and then I click tab. Whoa, it auto-completed it for me. So I didn't need to type the whole thing. And then after I finish the command, that's the whole thing. Change directory to this, and then I click enter. Great. So I am now inside this file. So let's get into it from the graphical user interface. I'm inside this directory, and there's this file called flag.txt. But you in the CLI, you still don't know that. So what you're going to do exactly? You're going to list the files, ls-l. Okay, great. So I know it's not a directory. Okay, and from the name of the file is .txt, so it's a file with an extension. So it's something that we run or open or read. And then we have the permissions. Now, before we do the permissions again, I want to, you know what? Let's do the permissions. Go back to the permissions. Now, just look at the dashes and the letters. The first three letters, okay, forget about the first character. Okay, this one specifies the file type. Okay, the next three by themselves are about the owner. Okay, so in owning, okay, in files we have three terms. We have read, we have write, and we have execute. Okay, so when you go up here, the three terms, it's only read and write. Okay, the first three terms are for the owner, the second three terms is for the group, and the last three is for others, maybe other groups. Okay, so the group is basically the group that the owner is part of. Okay, we have groups and users on Linux. So the owner can only read and write the file. The group can only read the file, so anyone else on the group can only read the file or the folder, and any other person can only read the file or the folder. Okay, so if you go back here, flag.txt is only is only readable and writable by who? By the creator. So I can only read and write the file. I cannot execute it. Okay. The people in my group, which is a group of students, can only read the file, as you see. So we take three right like this. Write and execute is not available. So they cannot do anything. And then we have other groups can only read the file. Okay, so we have understood permissions. Permissions are representation. We know how to read these. Okay, they're basically 10 letters. Okay, we know these. Dash. Okay, great. So let's get to reading the file content. Okay, and the terminal. Okay, so we have flag.txt. How could we read its content? So we're gonna learn about a new utility called cat. So when you type cat and then space, and then you type the file name flag.txt, and then you click enter. Oh, it printed the whole content of the file. Great. So what do they exactly mean? They contain flag, which is it shows head is fun. Okay, we're gonna learn about utility called head in a second, and then we have grib is fun. We're gonna learn about grib now, and then we have tail is fun. We're gonna learn about tail in a second. Okay, just a second, guys. Okay, everyone, sorry. Let's get started with actually filtering the output of the file. Okay, so we have read flag.txt. It has content. I'm sure you guys worked with a notepad before. So when you want to open a text file, you open up with notepad. But on Linux, we use cat. Okay, there's another utility. It's a text editor called Nano. Okay, you click enter, you type in Nano, you click enter, and then you click space, and then you type in the file name, and then you click enter. So it's basically a text editor, but in the CLI. Okay, but we don't really care about this one right now. Okay, so how can I really just get the first flag? I don't want to print all of them. I just want to print the first one. Okay, so the thing I'll do is that I will do cat. Okay, sorry, no, I will do head. I'll type in head, and then I will specify the amount of lines I want to print. So I will do -n, and then 1, and then I will do specify the flag.txt. Okay, so what does this do? We have head and then -n. I want you to print only, start reading from the top and then only iterate through one line. Only print the first line, okay? And then I want you from this file, okay? If we did, for instance, if we did 3, it will print the first line, the second line, and the third line. The second and the third line, we don't care about them because they're empty. So we could do -n1 flag.txt, and then we click enter. And as you see, it didn't print anything from the file but the first line. What if we wanted to, for instance, take the last flag? Okay, we want to only take the last flag. So let's talk about the tail command -n and then 1. So this is similar to the head, but it reads from the bottom. It doesn't read from the top. So we see tail -n1, and then we specify the file name we want to interact with. Tail -n1. Okay, of course there's a space between the n and the 1, and then I want you to read only one file from the end of the file, okay, the last line, and then you click enter. So it will only print for you the last line in the file. Okay, what if I have so much text in the file and I only want to print the content of, for instance, this flag, but this flag, there's so much lines, I cannot know how much distance in them. So I want to print all the flags that is in this file. So we are going to get back to the cat command. So we are going to do cat flag.txt. Okay, flag.txt. And then we're going to learn about something called piping. Okay, so what is piping? Do you guys know the vertical sign in your terminal, on your keyboard, which is basically looks like this? It's not a parenthesis. Okay, it's not a minus. It's not anything. It's like a long sign that when you do shift and then you do something above enter, and then you click space, and then you specify another command we're going to learn about now. It's called grip. So I want you to grip anything that starts with the word flag. So we're going to take flag, space, and then specify this word flag. So it will grep and print all the files that all the content on the file that has only the lines that contains this content. Okay, so it won't print the empty lines or anything else. Any line that have flag, anything that have a flag, okay, it will print it. So any line that contains the word flag, it will print it for me. Sorry, guys. Apologies, just had some difficulties in connection. Okay, so let's follow up where we stopped. We were at showing and printing all of the lines that contain the word flag. Okay, so we may have a lot of text in the file. We want just to print the places that contain the word flag. Okay, we don't want the empty lines because maybe in some scenarios the file content may be massive, may contain gibberish data. We don't want that, so we just want to print the lines that only contain the word flag. I'm sorry guys for the delay. Okay, so we shall get started with the next slide. Okay, the next one
Abdulrahman,
is
please
about yes.
share your screen.
Sorry, I didn't hear your question.
Can you share your screen, please?
Oh, my bad. Sorry. Just
It's fine.
when did I stop it exactly? Okay.
You showed us the head and tail,
Mm-hmm.
but now I think you would show us the grip.
Okay. You guys saw the cat also, or?
Yes, we did.
Okay, great, great. Is everything clear? If anybody have any questions about this section, because we're gonna end it. If anybody have any questions about it, please raise your hand. No one have any
Can you
questions?
go back briefly? Yeah, can you go back briefly to the cat section? Just
Okay.
in the end.
Okay.
Thank you.
Okay, so we have a text file, it's flag.txt, and as we did previously, cat prints the whole content of the file, just takes what's inside the file and prints it for me in the terminal. Now I want to filter this input. Okay, I want to filter this output. So this whole output, okay, this whole output, I'll be piping it using this sign, okay? And this whole piping will be controlled by this command. Okay, so this command does decide, whatever this command is, it does decide what is going to be the output. Okay, now what we did is that we printed the whole output, we piped the whole output, and then I said I want you to grab all the lines that contain the word flag. Okay, so grep works by grabbing a string from a whole line. Okay, so when you say grab flag, it won't just grab the word flag, but it grab the whole line. And that's what I want, because as you see, I didn't need to print the whole file content. I just printed the lines that contain the word flag, which matters for me, which I will take these flags and submit for maybe we're doing a CTF competition, or maybe you're filtering some functions in a file. You take the strings in it or whatever. We're going to take strings, inshallah, in the malware analysis workshop. Not for now. So let's move on. Is it all clear?
Yes, thank you so much, Abdulrahman.
Okay, you're welcome. So let's talk about the permissions. So in permissions, how do we calculate permissions? When there is a utility called chmod, okay? Chmod gives us the ability to control the permissions of the file. Who controls this file? How do we exactly who got access to it? Who can write it? Who can read it? And who can execute it? Okay, so if we did chmod, and then if we go back here, how to calculate it? So we have three modes as we specified before: read, write, and execute. Okay, so we have it for the owner, we have for the group, and we have for other groups. So for each group, for each section, we have three modes. We have read, write, and execute. Okay, so we need to calculate this. And just quickly in your mind, you have read. The value of read is always 4. The value of write is always 2, and the value of execute is always 1. Okay, so let's say, for example, I want to for the owner, okay, I want the owner to read, write, and execute. So I will add up 4 and 2 and 1, which will add up to 7. And I want the group to read and execute only. I don't want the group to edit, anybody in my group to edit the file. Just read and execute the file. So I would add up 4 and 1. So you could see the beautiful structure here, that you could control the file permissions from basic maths that are built in Linux. Okay, and if you want others also to just read and execute, you will do 4 plus 1. If you want others to only read, okay, you would only type in 4, okay, which will be output as 4. Okay, so if we want the owner to read, write, execute, anyone in the group to read and execute, and others to read and execute, it would end up in 7, 5, 5. So 7 is for the owner, and 5 is for the group, and for others is also 5. So we will end up with the with the number 755. So we will type in chmod 755, and then we will type in flag.txt. Then we click enter. Let's make ls-l again to see the permissions, and exactly as we wanted it. The first user, the owner who made the file, which is me, is going to read, write, and execute as we wanted. The group, the people with me in the group, will only read and execute as we want it. They're only gonna read and execute, and the other people also in the last 3 digits and the last 3 characters are also going to read and execute. Okay, so hopefully you guys understood permissions. Is there any questions before we move on? Great. I think there's no questions. Okay. Let's move on to, this is, I think, repeated. We don't need this. Okay, now let's move on to processes and system monitoring. I'm sure you guys have used the task manager before, okay? You guys have used the task manager before, and you see processes running, right? Like when you go to the browser, let me show you. So when you go to the system monitor, okay, and then you view the processes that are running. You see Brave, Bash, whatever you guys have. This is like the task manager. But in the command line, we don't have this graphical user interface interaction, right? We cannot just right click and then we could say just, let me go to Brave here. Cannot just like right click and just kill or stop the process, okay, or terminate. I don't have this graphical user interface, so I need to know the commands, okay? So the first command that we want to learn, okay, is px AUX, which will print all the possible processes that are running on your system, all the processes with all their data and information. Okay, so you print enter. Okay, and it will show you that you now, of course, a normal Linux system does have hundreds of processes. It prints hundreds of processes. Okay, but for you guys in the Docker container, it's pretty minimalistic. So it's just showing for you the shell program that you are connecting to the operating system, the shell that you're running, which is bash, and the psux. So it was actually running while it's running. So it showed you that it was running, right? So you could see some information about the processes here. You have the user who started the process. You have the process ID, and we're going to use this in a second. We see how much CPU and memory each process is using. So PS space AUX prints for you the whole processes that are running on the system. Okay, now let's take this scenario. Okay, let's take this scenario. I have a process in the background that is running. Okay, I have a process in the background that is running, but I want to kill that process. Okay, it's really heavy in my system. So don't run this, guys, but I'm just showing you this. Okay, so let's imagine we have sleep. Okay, sleep for like 10 seconds. You know what, 100 seconds. Okay, and then I do a space. So when I do a space, I write in the sign and. You know the sign and from the keyboard. What this exactly does, it does execute a command called sleep 100, which will sleep for 100 seconds. And then it does and basically a shortcut in the Linux command line in the bash, where in the bash shell will give you the ability to run commands in the background. So when we run any command, we are waiting for the output to finish, right? But in this case, we are not going to wait for the output to finish. Okay, we are just going to click enter. Okay, and the system is basically executing the command sleep 100, which the system is not sleeping, but it's just waiting, counting for 100 as a sleep. That's it. It's not doing really anything. It's just a blank command, just for the sake of showing you guys this example. So let's run PSA space AUX again, and we could see there is a process that is called sleep 100 that is running. Okay, great. But I don't want this process to run. It's heavying my system. Maybe some processes are very massive, and maybe you're running a script, you're running some compiling stuff. You want to kill them. So you go to the PID. Okay, you take the PID, which is short for process ID. The system gives each process an ID. So you take the process ID, you Control Shift C. If you are on the CMD, I believe it's Control C, but don't need to copy it. Okay, it's really short. So you're gonna type in a new command. We're gonna type in kill space and then 30. Okay, make sure you do not kill the wrong process. Make sure you do not kill this, because it will get you out of the bash shell. Okay, out of the SSH connection. So specify the PID and then click enter. So it killed it. Let's do psux again. And as you see, it's not running, and it tells me this was terminated. Sleep 100 was terminated. So that's how you could kill a process that is heavying your system on a Linux system. Now, guys, this is just a basic overview of Linux. We're not going that much deep. I'm just giving you an overview of what you could do when you log into a shell. Inshallah, if you guys wanted another workshops about Linux, we could do, but we cannot just compress the whole thing in 1 hour and a half. Okay. Okay. Let's go back to the slides. Not really something important. So let's talk. We talk about PSX. We did this simulation already, and then let's talk about networking. Okay. Now, what is networking? How do we exactly know networking on Linux? Okay. Now, the very first command that I want to teach you guys is IP space A. And what does this do is it does print the networking interfaces. You know when you have a Wi-Fi card in your computer? Yeah, this is similar, but in a software version. Okay, so you click enter, and then it will print for you in the Docker container. It will print for you the interfaces, the Wi-Fi interfaces that you have on your system, on the operating system. Now, Linux have its own way to coordinate the Wi-Fi interfaces. But mostly you have one Wi-Fi interface. Like if you go to my own system and I type in IPA and I click enter, I have so much IP interfaces because you guys are connected to my device and a Docker container. And so as you see, guys, each one of you have their own Wi-Fi interface. Okay, each one of you have their own Wi-Fi interface. This is all of you guys. Okay, but my original Wi-Fi interface is this one. Is this one that I'm connected to my home Wi-Fi right now. And so it's called WLO1. Maybe if you were using an Ethernet, it would be called ETH. It really depends, but it's more of your Wi-Fi card. Okay. So how could you get use of this? You could get use of this by knowing your IP address on the network. So if I go my IP address on my local network, by the way, this is not a public IP address, so don't worry, don't try to get something out of it. This is a private IP address on my local network, which means that if I could tell who am I to the router, okay? So if I'm scanning a network, if I'm scanning a Wi-Fi network, I could scan, like I could tell, oh, when I join the Wi-Fi, oh, this is the subnet of the Wi-Fi. This is how IP addresses look on this subnet. So I would just take this IP address and scan, for instance, like for example, I would copy this, okay? And I would do, guys, you don't need to know this, but I'm just giving you as demonstration as hackers. What we do is that we, for an example, do 0 to 255. There's something called subnetting. You don't need to know it also, but just showing you a case from 0 to 255. There are hosts that are inside this subnet. Okay, subnetting is another whole topic. We don't want to get into it, but just so you understand how, you know, what does IPA prints for you? It prints for you the IP address in your local network and on the LAN, okay, in the borders of your router, okay. So okay, so we have LO, which is a loopback. It's basically it's a Wi-Fi interface that the Linux system uses for some APIs, and I haven't really read about it deeply, but that's what I only know about it. And this is the ETHU, which is your Wi-Fi connection. Okay, now it looks a bit weird here because it doesn't look like a real life Wi-Fi interface, because usually Wi-Fi interfaces have more configuration, but this is just a Docker container, so it's a minimalist Linux device. Great. So we have network basics. Okay, great. So let's talk about netstat. So we have knew our IP address on the local network. We have known about the subnet. How could we see the connections that are happening on our Linux server? There's a command called netstat. Netstat, and then you do dash, and then you take TULNP. This is the full form, TU-TULNP. This is the full form for printing all the connections that are happening on your Linux, whether it's a UDP connection, whether it's a TCP connection. You don't need to know TCP and UDP, guys, right now. It's basic, but if you don't know it, it's totally fine. But just so you know, if you want to print all the connections on your system, you basically use netstat, netstat, and then dash TULMP, which will print for you all the connections, network connections that are whether connected to your local interface or your Ether interface or your wireless interface, whatever, any interface, it will print all the interfaces. And then you go and just click enter. Okay. Now for you as a Docker container, guys, there's no real connection. Let me see if I can do the, you know what? Never mind. I will show you from my device. Netstat, and then grab Brave. Okay. So as you see in here, I have printed the netstat, the whole thing. Okay. It's a really massive output. There's a lot of connections, but I want to grab the Brave connections. I want to see what type of connection on what port is being the Brave browser using. Okay, the Brave browser is using port 5145. I don't know what service is this, but it's using it on a UDP protocol. When you inshallah later learn networking and learn about ports and subnetting, inshallah, this will seem very clear and very fun. And especially when you do an investigation, you see the connections that are connected to your Linux server. You see maybe someone hacked your server, so you immediately do a netstat, and then you complete the command. I don't want to print the whole command because it may expose some information about my local network, but just so you know, if you did not do Brave, okay, it will print a lot of information, okay, not that much, but still it will print you every connection being done on your Linux machine. Great. So I have gone through a massive milestone. Guys, do you have any questions? No
Maybe
questions?
at the end, not now.
Inshallah. Okay, great. So we have Bing, we have traceroute, and then we have log and redirection. Okay, we're gonna finish this quickly because we only have 10 minutes left. We actually have 15 minutes left. I'm gonna have an extra 5 minutes for questions and career advice. Okay, so let's study another two commands. Bing and trace route. Now these are two. These are my favorite when I first started in the terminal. The first one is Bing. Let's click now, guys. Type in clear, the word clear in the terminal, and click enter. This will clear the terminal for you. Okay, that's another command. I hope you guys are taking notes, because we've learned so much commands so far, because an average student doesn't learn this much in 1 hour. So I'm sorry if I'm trying to rush everything in one session. Okay, so let's learn about the word Bing. Okay, what is Bing exactly? Bing is a command that uses the ICMP protocol. Okay, no need also to know about the ICMP protocol, but just so you know, it's just a fact. Okay, we have different protocols like the TCP protocol, the UDP protocol, the ICMP protocol, the HTTP protocol. There are different networking protocols that are programmed on every device in the world, and they all share the same protocol, right? They all, so that they could be able to communicate, right? So if I had like a configuration A and you had a configuration B, we won't be able to communicate. Maybe like if I speak German and you speak English, we won't be able to communicate. So protocols gives us the ability for devices to communicate. Now, this is not a networking workshop, but just to give you an overview what protocols are. Okay, it's like a unified rule for all devices to be able to communicate no matter what they are. Okay, so we have a Bing, and then we want to Bing a server. Okay, now you could specify the amount of Bings. Bing is a command to see if the server actually responds to you, if the server is alive. So what you will do is -C, and then you will say, I want to Bing the server 1 time, just to make sure it's responsive. I want to go with google.com, and then you click enter. Okay, we received a response from google.com. So we have 64 bytes as a reply. Okay, and we see ICMP sequence, TTL. I'm gonna tell you what a TTL is in a second now. But as you see, we have Bing at google.com 1 time. I want to, for instance, Bing google.com for like 100 times. Okay, google.com. Okay, and then click enter. It will keep binging Google. It will show you a live reply back and forth communication between your device and Google servers. Okay, so it's showing you the ICMP count. It's increasing every time we add another packet. And then we got the TTL. What is the TTL exactly? Tell us. Like, what TTL is short for time to live. Okay, now this is not a Linux thing. It's more of a hacking thing. Okay, a tip I personally use, without scanning the entire server, I could just Bing it, and I could tell from the TTL what type of operating system is running on that on that server. Okay, now TTL, if it was 64 and less, it's probably it's a Linux. Okay, if it was 64 and less, it's a Linux. If it was 128 and less, it's a Windows. Okay, note this down. If it was 128 exactly, maybe, or maybe less, it's sort of a Windows. Okay, they have different numbers: 128, 127, maybe 120. But if it was 117, maybe it's some sort of a router or Cisco router. Okay, so remember, 64 and less is for Linux. Okay, you could tell, oh, I'm binging a Linux server. Maybe this website is hosted probably on some sort of a Windows server. I'm not really sure. But you could tell from the TTL what operating system you are binging, you are communicating, because all servers, when you bing a server, it's an operating system. All computers have operating systems, but they have different configurations. They have different versions: Windows, Linux, Debian, Mac. So, so that's the use of Bing. We assure the availability of the host we are trying to communicate with. Like, for example, I'm trying to scan a host, okay, using Nmap. It's a tool to scan different devices on the network. And then I do Bing-C to make sure, without the -C actually, just Bing, okay, and it will keep binging the host. If it didn't reply with anything, that means the host is not alive, or it blocks the network traffic for him. Okay, so I cannot really interact with him. Okay, that's another command. So let's clear the terminal. Let's move on to the next command. Okay, now traceroute is an interesting command, as it helps you to understand the internet better. Okay, when you do trace route, okay, let's type traceroute, and then we type in 8.8.8.8. It's similar to google.com, but this is their DNS name. Okay, you don't need to really know about this, but just type 8.8.8.8. Okay, or you know what, never mind, just type in google.com. I don't want to overcomplicate things for you guys. A traceroute as you see, it shows you what is going on when you bing a google.com. It shows you the journey from your router to your to the Google server. Okay, you could see all the IP addresses this the internet is going through, so that they could deliver for you that google.com is bingable. Okay, so this is your local network IP address. Of course, this is Docker, and then you get out of the Docker to the original LAN network, and then you go through the stages of Ittisalat. Ittisalat will deliver you to the servers of Google, and Google, it goes through some stages, and then it takes you to the original Google server. Of course, Google it has a massive data center, so it's not just. Yes. Do you have any questions? Okay. So it takes you to the Google server. Okay, so it shows you the journey through going through devices. Okay, I have first thing passed through my this is my Wi-Fi interface, and then I jumped to the router, and then the router took me to this IP address into Ittisalat, and then Ittisalat, another server in Ittisalat, I think, and then I have hopped into went to USA, the wires under the sea, and then I went to until here I reached the final destination at google.com. So traceroute also helps you to trace websites, gather more information about them. Maybe if you have a suspicious IP that is connected, when you found it out with netstate, okay, when you did netstate and then you did netstate UPL, I think, I remember. Yes, TULNP. Okay. LNP, and then you found a suspicious IP address. So you do traceroute to see what are the connections that are going on. Okay. So hopefully that was clear, guys. Okay, we only have 5 minutes, and yeah, we're nearly done. Okay, great. It's this one is really easy. This one is extremely easy. It's really simple. So imagine I want to store my output. Okay, I want to store my output, and then I want it, for instance, I ran bing-c200, okay, google.com. So I want to see if google.com will respond to 200 bings. Maybe it will go down in some second, in some bing it will go down, so the bing will tell me, but I'm gonna go away, okay? I'm gonna go away, or maybe I'm running this in the background, okay? So what can I do is that I could store the output using the, let me just maximize this. Yeah, this lift going to the right sign, okay? You see the sign? We have it on the keyboard at the bottom right. You could type it in, and then you type in the file that you want to output you want to print the output of Bing in. So out.txt, for instance, or maybe out.log, okay? It's always a good practice to name your files over to name the file extension over the use that you're going to use it for, or the practice that you're doing. Maybe I'm logging down the activity of this command, so I'll just call it log. It doesn't really matter if you called it text, but just a good practice. So I'm going to click enter, and you just wait. Okay, you just wait for the command to run. Okay, it's not going to print anything in the terminal, because everything that is being printed in the terminal is being taken and put it into this file. Okay, now I want to stop it. Okay, okay, enough. I don't want to do this anymore. I will do Control and then C. Great, I have stopped the process. Okay, how could we read the content of the file in CLI, guys? Tell me, what is the command that we could use to read the content of the file? We have did this previously. You guys can type this in the chat if you want it. You could type in the command that. Come on, I'm waiting for answers, guys. What is the command that prints out the content of the file? I just explained this. I want to print the content of the file. ls is, I don't know, it's near, but it's not as the file that we wanted. It's not, sorry, the command that we wanted. ls prints the files in the current directory. Exactly. Thank you. What's your name? Asmi. Sorry if I pronounce your name wrong. Exactly. Thank you, guys. Thank you so much. It's cat. So cat prints the content of the file into the terminal. So we type in cat-log out.log, and then we print the output of the file. Wow, we have stored the output without even needing to print it in the terminal. And then we have printed the content of the file. Okay, what if I want, as we said before, what if I want to run the same command, okay, but I want to keep using the shell. I want to keep using the shell. Like I don't want the terminal to hang as it did before and just wait for the command to finish. I could also add the and sign. So I'll print enter. Okay. So there's a process in the background. I could keep working. Like I could type in ls dash l. Oh, I can see the file, but it's still running in the background. Okay. I could do ps aux, and then hey, there's this running in the background. There's this process. Okay. How can I stop it? Well, I take the PID, kill 42, enter, and we do ls. Sorry, we do ps aux. It tells you that it was terminated, and then we do cat.log. We see it's different from the, I think it's different from the last output. It has, the last one has 20, this one has 22, so it's different. It overwrites the file again. Okay, it deletes everything in the file when you do piping again into the, sorry, redirecting the output into the file. It deletes everything in it, and it writes again. Okay, so it will keep starting binging from 1 to until it did 22. We stopped it at 22. We killed the process at 22. I hope I did not rush anything, guys. So this is this. Let me just take a look at the slides. I think this was everything for us. We don't really need to get into these. They're really a bit unnecessary. But I think that's everything for the basic commands of using Linux. I know we have wasted an hour and a half just for a few commands, but that's how you learn Linux. Okay, so where to start learning Linux? Maybe I'm not the best person to teach you Linux. There is way better resources out there. If you're someone who likes challenges, if you're someone who likes to interact practically, by the way, all these resources have practice. They're practical. But if you're someone who likes to dig into the labs and have practice, you can use Over the Wire. It's a online. It has its online SSH connection stuff. Let me show you guys. I'm just Over the Wire, and Over the Wire is a website that has its own servers that you could connect to, and every time you solve a challenge in the SSH connection, as we did here, we have an SSH connection. You have, for instance, you do ls, and then you have a flag.txt. You do, like for example, you do cat flag.txt, and then you have a content. The output of the content of this file will be a password. Like if you go to Bandit here, yeah, Bandit is the right stage. You start here. You go, for instance, level 0, for instance, and then where's the, let's connect to the SSH here. What is the username? Yeah, SSH, sorry, SSH Bandit, just to make sure I'm delivering actual right content. Bandit, sorry, Bandit 0 at, and then the server that we wanted. You connect to the server using SSH. We specify the server, and then we specify the port. They have a customized port here, and then you click enter. Okay, just type yes, and then it will ask you for the password. Okay, the password is this. Copy it, paste it, and then you are connected to their shell. Now the next challenge is to find the password to the password of the next challenge is in the file that we have here. So ls, we have readme, so we're gonna do cat readme, and then it says here, congratulations, your first step into Bandit game. So I gave you guys the answer for the first question, and the password you were looking for is this. Okay, so we just exit, we go back. Okay, we have Bandit 0. We have finished Bandit 0. We're going to Bandit 1, and then we're going to copy this password and paste it in here, and it will take us to the next level. And this goes on and on. Okay, so I'm not going to help you with the rest of the questions, but it's an amazing website that it has like 33 stages, 34, that you could solve to actually master Linux working with the command line. But of course, there are other websites like Hack the Box. It's extremely useful. Hack the Box Academy is an amazing place. I myself have a subscription on their website. Okay, I hope you guys, I'm not taking the workshop too long for you guys. Thank you so much for being this long with me. But I just want to show you the models that Hack the Box is offering for us. I think it's for free. Okay, so Hack the Box also is offering a model called Linux Fundamentals. If you want to learn Linux in the real way, it has its own labs, it has its own questions, it's guided. You could go in there and solve the questions. There is labs, you solve, there's a whole details about, they're very concise in the theoretical parts and they're very practical. I like this about Hack the Box. Um, Similarly, Try Hack Me is an amazing website. If you are someone who likes to read books, I recommend starting Linux Basics for Hackers. This covers everything you need to know about starting with Linux and cybersecurity, Linux and cybersecurity at the same time. You know, you mix both. Okay, and if you want to dig deeper into Linux, also another good read that I have personally had an eye on is how Linux works. It teaches you commands on Linux and how Linux internally works. But this comes after reading this. So inshallah, we're going to be having also another sessions. I guess most of you guys was in the last session. This is the second session. Inshallah, we have Wazoo, static malware analysis, analyzing malware, and then we have machine learning. We're going to use the malware we analyzed the first time using machine learning. Okay. Guys, if you want to join our Google Developer community, you could scan this QR code and join our WhatsApp group. And I think this is the Q&A section. Now, if you have any questions, please proceed by asking in the chat, or you could ask directly through the microphone. Yes.
I have a question.
Yes.
Is it secure for me to use Linux?
100%. Using Linux is secure by default. Linux is built as a secure by design. Its design is made for developers to start to use it comfortably, because it's really difficult to develop malware for Linux, because as we learn about permissions, how strict they are, we have taken an eye on them. This is just a drop out of the sea of permissions. There's much more advanced configurations like the firewall and the SE Linux. There's much more configurations that are built into Linux to make it secure. It's secure by design, we're not building features above it. So that's why it's not bloated and it's secure by design. So it's extremely secure to use it. Okay, but always it's not 100% secure. Nothing is 100% secure, but it's much more secure than Windows and Mac OS.
Okay, got it. Thank you.
No problem. Okay, Hadil is having a question. Okay, Wissam, we're going to answer your question now, but let's see Hadil's question. Thank you so much for the workshop. You are welcome. It was very helpful. I have one question. Please do advise computer science. 100%. If you are someone who's studying computer engineering and you're interested into programming, I think it really depends on what you're going to do in the future. Okay, but using Linux for a while, it won't hurt. Okay, it won't be bad for you. You could install Linux alongside with Windows. Like you could partition your disk. Okay, you could look this up on YouTube. There's so much tutorials about this. Or you could use a virtual machine and install Linux and get yourself regulated to it. How to serve the documents, how to install stuff, how to configure firewall. It's important. I do personally advise anybody under the IT department, computer engineering, software, cybersecurity. Yes, please use Linux. Okay, Wissam, yes, you had a question. Yes, please go ahead.
First of all, thank you very much for this very informative and insightful workshop. I just want to ask, so do you recommend using Linux or Windows for me as a university student?
As a university student, I would recommend for you, if you're never experienced with Linux, keep using Windows. Do not get yourself into this rabbit hole of configuring and troubleshooting and going into, but if you are willing to use Linux, if you want to move to Linux, give yourself maybe 2 to 3 months of a side using, maybe install Linux as in your side laptop, or maybe in an old PC, and try to learn to use or use a virtual machine. If you felt you are regulated to using Linux, you can fully migrate to using Linux. That's personally, that's the best option I have ever done in using computers for me.
Thank you very much.
No problem. Any YouTube recommendations for Linux? Okay, that is a very good question. Okay, I think I have a guy. the guy you're asking for, but he is a network Chuck. I'm sure you guys heard about him. He's a pretty fun guy to watch, and he was one of the very first YouTubers that got me into learning Linux. Okay, Linux. Yeah, here it is. Okay, so thank you. So he got a whole playlist about starting in Linux. I believe if you watch this, let me just copy and share the playlist with you guys. I'll just share. Yeah, if you watch the whole playlist, I think it will get you started with basic commands. He will set up things for you. He's a pretty friendly guy. His explanation are so smooth and swift. I personally recommend for you to watch his whole playlist. It's pretty short. I think it's like less than 2 hours, or no, less than 4 hours. But I recommend to watch this playlist if you want to get started in Linux generally, not just for hacking. Yeah. Abdulaziz, yes, go ahead, please. No problem. Yes, Abdulaziz, go ahead. Can't hear you. Do you have any questions? I think he raised his hand and forgot.
Can you hear me?
Yes, I can hear you.
Yes, I have a different question.
Yes, go ahead, please.
How do you isolate your home server from your home network?
Well, this depends on your router configurations. I personally use my router configuration. You go to the D-Link URL, okay, and there's a feature. I think it's on all routers. I'm not sure if it's on your router, but mine is a D-Link. So you go to the configurations and you go to port forwarding, and inside port forwarding, there's this feature called virtual server. You specify the local host. The computer on the local network. You get its private IP address that we talked about earlier, and then you specify the TCP and UDP ports that you want to port forward outside, and then you click save. And the way you get your public IP address is through the internet. You can just look it up. Go ahead and look up what is my IP address, IPv4. Make sure it's an IPv4, not IPv6, because there's a massive difference. So IPv4, and then you try to connect to it, or maybe if you're hosting an HTTP website, you visit the IP address. Hopefully, it will work, inshallah. If you have any questions, you could.
What if you need to communicate with this device from a different device on your home network?
That's from outside, you mean?
No, from your home network.
Well, you don't need
Example,
that.
I have 2 home servers.
Yeah. Well, if it's inside the network, you don't need to interact with the router, because you guys have a sort of a circle, okay? A circle that the router is making for you guys inside. It's like a sandbox. You guys have your own IP addresses, okay? Maybe your IP address for your device is 192.168.100 and 172, and the other device is you need to scan the network, of course. You need to find the IP address. You could go to the dashboard of the router. I think it shows you all the IP addresses of the network, of the devices, different devices on the network. Maybe the other device is 192.168.100, 164 maybe. So you visit the URL. Maybe it's hosting an HTTP service. There's a lot of complications about this, but you don't need to really expose any port or virtual server. It's locally. So LAN communication is, you don't need to do anything. It's, you guys could talk. IP addresses are clear with each other inside the network. Is it clear?
Yeah, it's clear. Can I have your email, please?
My email?
Yes.
Yes, I will send my email in a second.
Thank you.
You are welcome. Is there any questions about the workshop? So you guys understood everything I explained, apparently. Amazing. I really am a good teacher. I believe there's no more questions. Thank you so much. Thank you so much. That's really nice of you. I believe that's the end of the workshop. I hope you guys learned enough about just basic commands using Linux, and you have enjoyed using the lab that I've made for you guys. And hopefully, inshallah, we will meet in 2 weeks in the Wazoo workshop. Yeah, I think that's the end. And alhamdulillah, we have done a good job today. If you have any questions, I'm still here. And
If you don't, you could proceed to leave. Thank you.